One individual had 3 potentially disease-causing mutations, and a proportion are just heterozygous for their substitutions. So in these disorders we can have reversion, so sometimes you may have had a pathogenic mutation that's then been lost. So that may be a feature of some of these individuals, but it's difficult to tell when you only find a heterozygous change. And of this group of individuals that we've looked at, amongst 31 patients, we've identified 10 of those to have Fanconi anemia, giving us a pickup rate of 32% amongst these individuals. To continue our work in this area, we've designed and are just starting to validate an extended bone marrow failure syndrome panel. So we now have further Fanconi genes identified. There's 3 newer ones that have been identified recently. And we're adding genes for severe congenital neutropenia, dyskeratosis congenita, diamond black family anemia, and congenital thrombocytopenia as well to our analysis. And we hope to launch that February or March time next year, once we've finished all of the validation work on it. So in summary, next generation DNA sequencing provides a single workflow for analysis for multiple gene panels. The simultaneous analysis of all the genes associated with the disorder enables speeding up of the diagnostic process. The data analysis is straightforward once the common sequence variants have been removed, and the analysis costs are often reduced. And lastly, I'd like to thank many of the staff in our service that were involved in the next generation sequencing, particularly Kevin Bly and Lucy Crooks, our bioinformaticians who've been involved in setting up the next generation sequencing data analysis pipeline, but also the many others involved in this process. Thank you very much.
Thank you very much, and it's a pleasure to have you here. We have one question, if you don't mind.
Thank you for the presentation. I just wonder if the old tests that we used to use for Fanconi, the mitomycin C and the EEV test, the detection rate of those tests is probably much higher than the panels. You say the panels only detect 50% of the cases.
Sorry, could you speak a bit more slowly? I'm missing the last bit of what you said.
Yeah, regarding the mitomycin C and the EEV test, the detection rate probably is much higher than these panels. I don't have a clear figure how much is, but for sure it's more than 50%. You say the detection rate using these 19 genes for Fanconi is only 50%. So my question is really clinically indicated to use these panels, having a better test before? And my second question is...
Can we just do the first one?
No, and this is very related. The exome sequencing wouldn't detect more than these panels?
So the phenotypic testing first for the chromosome breakage, often when samples are referred to us, they haven't had that testing undertaken before the samples are sent to us. So if that phenotypic testing hasn't been undertaken, there may be a different disorder than Fanconi anemia present in the patient.
Okay, that's fine.
Does that answer your question?
Yeah, I guess so. If there are no Fanconi, of course the detection rate will be less.
Okay, and the second part for whole exome sequencing?
Yeah, it will be the same. I mean, you don't know if there are Fanconi, you're doing exome, probably the detection rate will be low. I mean, no, 50%.
So, as part of our service, we don't currently offer whole exome or whole genome sequencing, although we do undertake those as research services, but we haven't moved into undertaking that as part of our own service. Yes, if they didn't have one of the Fanconi genes as the cause for their disorder, it's quite probable that you would pick that up through using a larger panel for sequencing.
Okay, thank you very much. Any more questions, either from the men's side or ladies' side? If not, then we have few words.
Yes, hello, I need a question.
Yes, go on.
First, I want to thank you for the very nice presentation. Second, you mentioned here that there are some patients which you were not able to diagnose by molecular.
Sorry, not able to diagnose
By the molecular technique you're doing here.
yes, that's right.
And are the patients who are heterozygous and they are in the clinical picture is typical for Fanconi. In these cases, what do you do?
The only other analysis we have available currently is dosage analysis. So we can currently undertake dosage analysis just for the Fanconi A gene. The main project that our bioinformatics team are working on at the moment is to be able to introduce copy number variation so that from the next generation sequencing output we can get not only sequence analysis data but also copy number variation data so that we're able to look for large deletions and duplications as well. So we're hoping that that will be available early next year, but it's difficult to offer that currently.
Thank you.
Any more questions? Right. We have few words from Prof. Adel Abuznada. Prof. Adel Abuznada is the director of the Center of Innovation and Personalized Medicine, and he is the deputy director at the Center of Excellence in Genomic Medicine Research. It's a privilege to have him here. So a few words from him.
Thank you, everybody. We're really sorry. We are way behind schedule. We were supposed to finish the whole day more than half an hour ago. And based on our schedule, we still have 3 presentations to go on. Those were supposed to be the presentations from Center of Innovation and Personalized Medicine. And so I talked to my colleague and I apologized to them. And it seems like it's going to be too late for everybody to start any presentations now. Therefore, you're scaring me, Ahmed. Therefore, it seems like we're going to have to end the session for today, and we will try to find time tomorrow. If we manage to stick to time tomorrow more, because I know that we have colleagues who couldn't make it from USA to us as well in the schedule tomorrow. So we'll try to place those presentations within the schedule of tomorrow. Again, I really apologize to everybody for being way behind everything, and for not. I apologize to the speakers, especially Dr. Ashraf and Dr. Aisha, for doing this today. And I hope you enjoyed the day, and we will meet you tomorrow morning.
Thank you very much for listening today and for your patience. Thank you very much. And see you tomorrow at 9 o'clock.